and use for only like it is a duplex or multi what is called, I forgot that which duplex it is, duplex or duplex,
You forgot.
I can't able to
It's full
remember.
duplex, sir. It has TX and RX pins.
Yeah, sorry.
It's very slow when compared to SPI and I2C. Um, it's mostly used to communicate between two controllers. It's a low communication when compared to I2C and SPI. I think so.
Yeah, it may be an legacy technology, but it is still extensively used in today's world also. Okay, mostly in the industrial setting, UART is still used extensively still to this very date. Okay, it is not going anywhere away for probably for next 2 decades or so. So you do need to understand UART communication and what are its higher level applications. Okay. I have a question to ask all of you. How many of you are familiar with the RS-232 and RS-485 communication standard?
I am little bit know about RS485 because I recently used Max 485 module to implement that RS485 in my um, project ROV. We are making some wired communication for ROV with the help of flight controller and S-bus based transmitter. Um, I am not used RS485 port, but I used Max 485 to implement the RS485.
Yeah, I have a small thing to say you. RS-485 is not a communication standard. It's an electrical standard. Okay, that's the thing people miscommunicate always. I've deliberately told that it's RS-485 communication standard, but it is actually electrical standard, which predominantly uses UART as a communication standard for itself. Okay, underlying communication standard.
Yeah,
Yeah,
it's a
and
it's a
top,
layer of
yeah,
it's a layer of UART. Am I right, sir?
it's not variant of a UART. It itself is an electrical standard which most of the time uses UART communication. Okay, most of the time
Okay, sir.
you can still use like SPI or some other communication standard. But in literally in my like last 4 years of experience, I only seen UART being used in RS-45 or RS-285. Sorry, RS-45 and RS-222 communication. But you can use other standards too. But it's most of the time it's just UART communication, underlying communication. Okay. And top of it, we have lots of other communication like DMX for 512, then Modbus communication, and whole lot of other communication standards, which itself only uses UART as the underlying communication standard. It's just like Modbus and Max 512 is frame formatting technology, which uses UART most of the time. Okay, so UART is not like an old technology. It's still an old technology, but it's still been used with a lot of other technologies. Like they call it a Modbus, they can call it a Max 512. Sorry, DMX 512. They can call it RS45, RS232, and a lot. But it most of the time it's just a UART communication with a lot of caveat. So I have told you all this, so just I can make you interested in whatever I am going to teach you next. Okay?
Sure, sure, okay, continue.
Yeah,
So
it,
Modbus is used for long distance, right?
it's lot of use in industry. There are two type of Modbus. One is the RTU and the other is the TCP/IP. TCP/IP is uses Ethernet communication, and
Mm-hmm.
recently they are also using Wi-Fi communication too. But most of the industry is just Ethernet communication. Okay, so Modbus TCP/IP. Okay,
Okay.
Modbus TCP/IP and Modbus RTU. Modbus RTU uses UART communication. Okay, yeah, UART RTU. And I'll be super happy if some of you guys just turn on your cameras. Okay, so if anyone is going to start the cameras now, I'm pretty sure not. Okay. एक जन ने चालू कर दिया, हार्दिक जी ने। या, अब मथेश जी और जो अपना शिवा रेड्डी है, ये सब चालू करेंगे। ओके, शिवा रेड्डी जी ने भी चालू कर दिया। मेरे ख्याल से हमारे यहाँ पे आज कोई लड़की नहीं है, तो हम सभी के सभी चालू कर सकते हैं। सभी की सभी की दाढ़ियाँ आ चुकी है, तो हमारे से कोई शर्माने वाला है नहीं। या, हम में से कुछ लोग जा चुके हैं अभी, क्योंकि हमारे यहाँ पे सारे लड़के आ चुके हैं। तो अभी जो जा चुके हैं वो कोई लड़की होगी। ओके, चलिए मैं अभी क्या करता हूँ, अपना विंडो शेयर कर देता हूँ अपना इंटरनेट स्क्रीन। ठीक है, हम सबसे पहले तो दो चीज़ें समझेंगे। वी आर एक्चुअली गोइंग टू अंडरस्टैंड टू थिंग्स फर्स्ट। ओके, my teaching structure is for as a resistor base like bare metal and also the Hall technology. So first we are going to cover the bare metal side. For the bare metal side, we have to go and understand the data sheet first. Okay, whatever microcontroller you are using, just open its data sheet. I have my own archives of data sheets, so I will simply go to my own archives first. Just get started first. Electronics. Just a minute. So microcontroller data sheets. Okay, history. Okay, all this microcontroller I have worked on. So F4, the F401. Okay, just get to the data sheet. And let me just open my, yeah. One is the reference manual and one is the data sheet. We are going to look at two specific things. One is the block diagram, which is like a super important thing to check out. Okay, it will tell us that how many UART actually we got here. Okay, can anybody please tell me how many UARTs we got here? Please.
Here two UART is visible. One
One
is
count
UART
of
0.
the UART is 6,
Yeah,
as we can see.
yeah. How many UARTs we are able to see here? USART and UART, both are the same, okay?
Three.
Okay. As you can see, we got the three UARTs, okay? UART 1, UART 2, and UART 6, okay? And we can also see that in which bus they are working on, like APB2 bus, there is UART 1 and UART 6, okay? Predominantly, we are actually going to use the UART 1 here, using the APB2 bus, okay? And the second thing is we have to go and check out our data sheet here. Okay, let's go to the data sheet first. Yeah, we are on the data sheet, and I can just open our register. RTCUR. Directly go to the registers. Okay, first is the status register. Okay, which tells that what condition that our UART is in. Okay, sorry, status register. CTC actually come in here after like a lot of long time period. Okay, there are a lot of statuses here that what is happened and what is going on right now. But the most important status are just a minute. Ah, it's not empty. Okay, RX not empty. It is the TX empty and RX not empty. Okay, this 7 and 5th bit is the most important bit when you are doing your bare metal communication. Okay, so what the seventh number says, transmit data register empty, means that whenever your data register is empty, it will be 1. Okay, and it is a read only. Yes, it's a read only register. Okay, RX and E not empty, read and write. Okay, section number C, read clear, write zero. Okay, it will be like if you read it, it will automatically clear itself. Okay, okay. Read data register not empty. Okay, whenever you receive a new data, the this register will be 1. Okay, this is the most important one. Other means like overrun error and other things, but yeah, we are just going to like ignore it for right now. Frame error and other things, parity error. Okay, like it will check for the parity bit and everything. Okay, data register. It is the data register from which you will send and receive the data. And second one is the baud rate. It is like super important one. It is like the Mantissa and fact, fraction information. They actually have provided you the mathematics to like put in here the values, and this Mantissa and everything is important because sometimes uh, simply dividing your clock register clock by a certain value is not always enough to give a precise baud rate in a lot of times. So this fraction value is more important. This is a major part, and this is the remaining after point part. Okay, and this is like the control register where you set up your UART communication. Like here, RX uh, like how you are say, like a transmit enable, receive enable, and there is a TX interrupt enable and receive not interrupt enable kind of thing. So you are actually also activating the interrupts and configuring your system, and there is a UART enable, like activating your UART itself. Like you see UART enable, which is UE, which is like the most important one. And there is the oversampling mode, oversampling like 8 bit and how many you want to send. Okay, okay, and there is like a word length and everything. Okay, most of the time you just don't need to configure it because most of the time whatever is the default value is like the most common communication standard for the UART, and the remaining configurations are like having some advanced communication standards been activated. Okay, so just most of the time you just leave it to whatever they are. Okay, and there is like transmit complete interrupt, and there is TX interrupt. Okay, TXT interrupt. There is a C1. Okay, there will be like a C1 2. Okay, okay. RX any interrupt, and whenever the data is received, the UART will generate an interrupt for it. Okay, and there is a transmit enable and the receive enable for the system. Okay, and there is a control register too. It is for the advanced communication like the link mode, and there is also like DMA communication, stop bit size, and all the other advanced communication which you need to do and to configure it whenever you want. And there is okay, there is like a control register 3, which is like a significantly more advanced configurations. We actually got here like a DMA. Okay, okay, DMA enable receive and DMA transmission, and there is a smart NAC enable and hard to fix. Okay, yeah, it is for like the advanced systems. Okay,
What is TMA? That is
it is the direct memory access. Actually, I am not going to teach you TMA in this course because simply the DMA
mhm.
is just significantly more advanced technology. But it is something which actually gives you a significantly more efficiency when you are communicating or using your microcontroller. Like you have to transmit a massive chunk of data with the help of UART. You don't do it manually. You simply activate your DMA and tell it to like transmit or receive the data. Like if you want to transmit like 1,000 bytes of data, you don't want to do it manually every time. You just tell the DMA to do the 1,000 bits of data transmit through the UART and DMA will do it for you. Or vice versa, if you want to receive it, DMA will do it for you. Okay, it's a direct memory access
Okay.
and it will like a really super efficient use. It is used for like super efficiency of your microcontroller. If you are like
Okay.
want to be a pro embedded engineer or microcontroller developer, microcontroller firmware
Mm-hmm.
developer, you need to know about the DMA.
Okay.
But
Okay.
but in this course, I'm just not going to teach you how to use DMA because it's like a completely different league of things. Okay.
Okay. Okay.
Yeah, when you are like already proficient in the microcontroller, come back and I will teach you how to use DMA. I'm probably going to charge each person 10,000 rupees at that case.
Okay. Okay. Okay.
Yeah, yeah, because DMA is just like a pro level thing. Okay. Guide time and pre-scale register. Actually, never used this specific thing before, and I never checked out what it is. But, yeah. Okay. Now the second thing, now we will can directly go to like a coding part, and I'm also going to use like a AI for it, so you will also know how can you how much you should use the AI for your coding purposes. Okay. And if you actually will able to if we able to find some mistakes in the AI's work, and I'm also going to point that out too. Okay. Uh, I have a disclaimer for you. In the past, I able to find the AI actually doing a lot of mistakes even in the ST microcontroller, but nowadays it does not do much larger amount of mistakes like simpler tasks. It still does, but in complex and for like less well-known microcontrollers, like for Novoton or Fadook or Haltech or same type of like even for the TI microcontroller, it does a lot of mistakes. Okay.
Okay. Okay. Which AI
Yeah.
you are using? Yeah.
The what? Which AI? We can like go for like the most common one. Like there is like Gemini, ChatGPT, or Grok, or some other. Which
Okay.
AI do you want to use?
So in ChatGPT, like we are you are using like which level? Like
I'm just using the more normal, the most cheapest one.
okay. Okay. Fine.
Yeah, we don't need to use like the most expensive one because all the AIs in the world are shit for the embedded development. So even if you use the most pro version and the most cheapest version, both are practically same for you. So why do you pay more for the same garbage?
Oh yeah. Yeah.
So ChatGPT or Gemini?
ChatGPT.
ChatGPT. Okay, F1. So we are just scroll into like write a bare metal code. Okay, and let's see what kind of code it actually gives us. Okay, it is giving us a lot of information how to do it and whatever you want to do it. Okay. Okay, here's a so there is a, like a DMS for another thing. But I am just interested in it's bare metal coding. Okay. 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 It is also giving me itself a fraction and Mentessa information too. Okay, but how to calculate fractal and Mentessa? Here, it is actually given us information on calculating Mentessa and this one, which is actually quite correct here. Okay. Okay. Here's like the our bow rate calculation. It has provided and how to calculate every remaining thing. 16 into bow rate. The heck it is it 16 into Okay, there is like a formula for that one. Yeah. Enable clock, configure GPU, disable UART, set baud rate, configure frame format, enable transmit and receive, enable UART. Okay. It is doing significantly more of yeah, it is enabling GPIO first and there's enabling the alternate function registers and output speed and remaining things. It is setting it for highest possible speed for the output speed, enabling UART. Okay, it did not activated. Yeah, it did activated UART in UART. Okay, right, configured the transmit keyword. Activated this one. Okay, so the 90 every remaining thing here. Okay, did good things. Okay, UART transmit to C section. Yeah. Okay, it is made. Okay, I have to say something. It did not made much of a mistakes, but it did made a one significantly big mistake already. How many of you can see here? This one, this information, transmit string. Can anybody tell me what kind of mistake does the AI had made? Hello, hello.
If we do any constant,
Hmm.
but here again it is increasing, right? How is possible? It is not possible, right?
No, no, it is actually using a pointer here. STR
Okay.
pointer. It is a pointer. STR. You can see the dot here, right? But it is
Yeah.
sending a string, but it is not comparing with this string with this specific characters with the null value. So it is going to make a big mistake here. This loop. This loop will go forever and forever. Okay.
Okay. Okay.
As long it does not find any null value, it will just this character will this pointer will keep going for forever. Okay, and is taking memory from a RAM. So RAM already has a lot of junk value in it, which is not a null value. Okay, most of the time it is not a null
Mhm.
value. So it can go for continually for unknown time period. So you should always like provide a null value character or some specific special character, which is just keep doing it. Whenever you provide directly provide a string to a pointer, the compiler always put in a null value at the end of that string. Okay,
Yes. Yes.
yeah, it always automatically put there. But when you are sending it through this while loop, you should always provide a null character. We already
Yeah.
found a
Yes.
big mistake. We already found a big
Oh, yes.
mistake inside this AI's output here, right?
Yeah. We have to make like star STF not equal to like
Null character.
slash zero.
Yeah, slash
That
zero.
finger code. Yes.
Yeah, so we did found a big mistake here. This is like a 10 character, which it is like doing it quite well. Like
Mm-hmm.
as long as it is not like TXC, it's still going to wait and everything. Okay, receive
Okay.
enable. Yeah, it's actually made it. You actually don't need to put like all this stuff here. Okay, so you actually
Mm-hmm.
don't need to put like all this stuff. It will like directly do that. Okay, just return the data register and it will directly return this. Don't need to do all this kind of thing. Okay, and here it is. So we did actually AI was extremely good at it. Okay, but we did able to find a one big mistake here. Okay, and this was
Okay.
actually an extremely simple code to write,
Hmm.
and it still made a extremely big mistake. You know that where actually it actually found this method to do it from Python.
Okay.
Yeah,
Yeah.
from
Yeah. Yeah.
Python. Yeah, from Python and from pick microcontrollers and probably from some other microcontrollers. We like pick to does support this kind of coding, and there is
Mm-hmm.
like some other microcontrollers which do does also like provide the same kind of coding standards. But there are like some other microcontrollers which do provide this kind of coding, but I don't know a single ARM microcontroller which does support this kind of coding. So none of the ARM microcontroller does support this kind of no ARM compiler actually does support this kind of writing of style writing style. But
Okay.
there is like Java, JavaScript. These both languages are like completely different. They have this specific kind of characteristics, and they are like the microcontrollers too. Mostly like proprietary microcontrollers, like Python, like another technology. Just a minute, I'll let someone in. Okay, yeah. So I was like doing what should I say? Roasting the AI here. Okay, so but a lot of things AI had done is extremely correct, and what it did, it made our life easier. But do not always blindly like believe in whatever the AI says. Okay, but a lot of things it did is was correct. Okay, so system has told us that we have to initialize our GPIOs first. Okay, let me just make a new project here, and then we can like start our course. Okay. By the way, I'm using an older version of STM32 Cube IDE here. So your ID may be a little bit different. You have to make all this project with the help of CubeMX, and I have CubeMX integrated into my own IDE here. So
Which version you are using? You
I'm using a
STM2?
one using like what should I say, 1 point something, 1.9 maybe.
Okay, okay.
Yeah, and right now the latest version is 2.
But why they integrated both MX and IDE, sir?
Well, the major difference is the IDE is for like the for it is integrated development environment for like writing code and every other thing, and QMX is the code generator. Okay, initializing target selector. I may have gotten myself into a bit trouble right now. Okay, I have to purge my IDE right now and task. Okay, so tell me about yourself. We have a little bit time in our hand. I think they actually need to like actually restart my ID again. It always takes a lot of time.
Sir, can you tell me something about like clock selection? When to use HSI and when to use PLL?
Well, HSI is like high speed internal clock, right?
Yes, sir.
Yeah, and PLL is like it's for amplifying your signal. Okay, it is like phase lock loop for increasing your internal signal. Okay,
Okay,
so
okay.
you need to use both of them. HSI is a high speed internal clock, HSIC, and I recommend that in your most of the normal work you should use like internal clock. And if you need extremely high time precision, you need to use external clock. And PLL is for like whatever clock frequency you need for your processor, you need to select it through the PLL while considering your actual clock source, like HSI or external clock sources. Okay, they
So
both are
like
inter.
means in what applications? Like normally we select HSI for normal usage,
Hmm.
but when to select PLL? In
Well,
what application?
well, PLL and HSI are interlinked. They are not separate things. You,
Okay, okay,
yeah,
okay.
whenever you are using HSI or any other clock source, you are always, most of the time, you are actually using PLL. Most of the time, because a lot of time the HSI is like 8 megahertz or something like that. 8 megahertz, maybe 4
Hmm.
megahertz. And you're probably going to need like 180 megahertz. So you use PLL to increase your clock frequency in that case.
Okay, okay.
Yeah. HSI is not like extremely high frequency. It's 8 megahertz, 2 megahertz, 4 megahertz. So you know that why we actually have like these smaller frequencies of oscillators? Okay, it takes a lot of time to activate that.
Okay, no idea. Can you brief tell me what is that clock frequency of small?
Huh?
You said oscillator we have to use less frequency something you said, right?
Yeah, let me just show you. I'm not going to tell you. I'm going to show you that what it means. Okay? UART parameter. Right now, I'm actually recording and using my software at the same time. My laptop is like not working at my full capacity right now, like not working as fluently as before. Let me just see how much my processors are actually, uh, what should I
So
say?
you can activate your PLL, laptop's PLL.
Well, it is already working at its like max clock speed right now, and you are actually going to see that how much it is like using all the processing power. I already like filled my view. Okay, it's still like hanging a lot. Okay, how much? Well, my fans are working at its like their full capacity, and you can see my processor is working at like its 99%, 98% capacity right now. Yeah, most of the time it is like around like 40% or something. Because I'm recording right now, it's working at like its full max of speed. So yeah, and I'm also using my graphics also. So 12% of my graphics, which is most of the regular period of time, it's always sitting at like 0%. So it's something. Yeah, yeah, my system is just working in my full capacity. Let me just show you a few of my systems. Okay, okay, we stop. So I'm pretty sure graphic wow we have for this one. Okay. No, it does not use any kind of graphics for specific animation. Okay, so you were asked for the HSI and PLL, right?
Yes, sir.
Yeah. Here you can see that here we got an HSI RC. It is like high speed internal RC oscillator, which is running at like 16 megahertz. And we actually got a lot of significant things to work with here. We got a PLL, it is like a main PLL, and we got some secondary PLLs also, but not in this specific setting. Okay, we actually have like some other PLLs too, like PLL2, which is PLL for I2C communication, I2S. And then if you are like using like H7, you may going to get like three, maybe four different PLL inside your system. Okay, I'm directly going to configure it with the help of just a single button. I'm just going to type like how much frequency I need in this specific section. Like I want like 84 megahertz. Just click here, press enter, and everything will be done by this clock configuration itself. Okay, it will find out the best configuration for like all other clock sources to give me like the best possible clock so that my APB2 bus, which will be running at its maximum clock frequency.
सर
Hmm?
सर पॉसिबल हो तो इंटरप्ट और कॉल बैक में बेसिक डिफरेंस क्या होता है हमारा? क्योंकि मैंने थोड़ा स्टडी करा था इंटरप्ट और कॉल बैक के बारे में, तो मुझे समझ आया था कि इंटरप्ट के बाद ही कॉल बैक्स यूज होते हैं, तो मुझे थोड़ा उसमें कंफ्यूजन था यार। मैं तो एक बार ये थोड़ा थोड़ा 5 मिनट उससे बता देते बेसिक
इंटरप्ट
डिफरेंस
इंटरप्ट के
एंड
ऊपर
कॉल
क्या?
इंटरप्ट एंड कॉल बैक के बीच का डिफरेंस, बेसिक डिफरेंस क्या है दोनों के बीच का?
वेल, दोनों के बीच में डिफरेंस डिपेंड करता है कि आपको क्या समझना है, क्योंकि कॉल बैक फंक्शंस होते हैं आपके, मतलब कि कैसे मैं आपको बताऊं।
फॉर एग्जाम्पल स्विच प्रेस कर रहे हैं, वो एग्जाम्पल लेके चल रहे थे, एक्सटर्नल स्विच प्रेस कर रहे हैं,
मोस्टली
एक्सटर्नल
मैं आपको
स्विच
एक चीज
प्रेस
बताता हूँ, कॉल बैक फंक्शंस मोस्टली सॉफ्टवेयर बेस्ड होते हैं, इसमें कोई इंटरप्ट होता नहीं है। पर मान लेते हैं कि कॉल बैक मोस्टली मैंने ऐसे सिस्टम्स में ही देखे हैं, जैसे आप कोई एलवीजीएल जैसा कोई ग्राफिकल लाइब्रेरी यूज कर रहे हैं या फिर आप आरटॉस यूज कर रहे हैं, तो वहाँ पर कॉल बैक सबसे ज़्यादा होता है। ये कम्प्लीटली सॉफ्टवेयर बेस्ड होता है, जहाँ पे आपका सिस्टम एक प्रोसेस को छोड़ के दूसरे प्रोसेस में स्विच करता है और आप किसी तरह का डेटा अपडेट करते हैं। तो ये मोस्टली आरटॉस टाइप के सिस्टम्स में होते हैं। और कॉल बैक फंक्शंस में आप कई सारी जगह पे कई सारे डेटाबेस को अपडेट करते हैं फ्रॉम लाइक एनी पॉइंट ऑफ टाइम। इवन आप कहीं पे कोई फंक्शन भी कॉल कर रहे हैं तो वो भी एक कॉल बैक फंक्शन जैसा ही होता है। या फिर आपने मान लेते हैं कि जीयूआई के अंदर में ये यूज किया है, बटन रखा है, तो उसका एक कॉल बैक फंक्शन होता है। मतलब कि सिस्टम ने पता चला कि ये है और फिर बाद में उस फंक्शन के लिए उस इवेंट के ऊपर आपको एक फंक्शन को कॉल करते हो, तो वो भी आपका एक कॉल बैक फंक्शन हो गया। इंटरप्ट के थ्रू भी आप कॉल बैक कर सकते हो, पर कॉल बैक हमेशा फंक्शंस ही होते हैं।
जैसे एसटीएम के अंदर हम जब अपना आई इंटरप्ट अपना इनेबल करते हैं, कॉल बैक फंक्शन आते हैं, आईपी हैंडलर्स आते हैं हमारे पास,
या
जो हम जीपीआई डॉट सी फाइल में देखते हैं, तो वो भी
हम्म
सारे हमारे कॉल बैक फंक्शन होते हैं। इसको हम टाइमर हम कॉल बैक फंक्शन को लिखते हैं, जो कैप्चर कॉल बैक वॉइड कैप्चर कॉल बैक फंक्शन हम लिखते हैं जो
या वो एक्चुअल में जो हाल के साथ में प्रोवाइड किया जाता है।
उसके बाद
जो
क्या आंसर?
या मोस्टली जो इंटरप्ट अगर आपका हाल फिर इंटरप्ट लिखा हुआ है तो वो पक्का एक कॉल बैक फंक्शन ही है। ठीक है, वो आपका इंटरप्ट फंक्शन नहीं है, वो कॉल बैक फंक्शन है। वो हमेशा उस इंटरप्ट के अंदर होगा।
तो हमेशा हमारा जब आईएसआर आता है तो हमेशा कॉल बैक फंक्शन आएगा, या हम बिना कॉल बैक के भी आईएसआर चला सकते हैं?
या पर आप
क्योंकि
असल में आप आईएसआर खुद में अलग सिस्टम है जिसके अंदर आप आपके खुद के जैसे चाहे वैसे फंक्शंस लिख सकते हैं। और जब आप इस तरह का फ्रेमवर्क यूज करते हो, कॉल बैक को इसलिए प्रोवाइड करते हैं ताकि आप जा करके आईएसआर के साथ में छेड़खानी ना करें।
तो जब हमारा आईएसआर चलता है तो हमारा कॉल बैक उस टाइम पे नहीं चलता, राइट?
अ,
ऐसा ही।
नहीं, वैसा कभी नहीं होता एक्चुअली में। आपके आईएसआर के अंदर ही, जो आपका आईएसआर का फंक्शन है, उसके अंदर ही आपका कॉल बैक का फंक्शन हमेशा इंटीग्रेट कर देता है। जो आपका जैसे अपना क्यूबएमएक्स है, वो आपके आईएसआर के अंदर, आईएसआर का जो फंक्शन होता है ना, उसके अंदर ही आपका कॉल बैक फंक्शन को इंटीग्रेट करके रखता है।
जब हमारा इंटरप्ट हिट हुआ, आईएसआर हमारा रन करेगा, उसका जो भी हमारे ऑपरेशन परफॉर्म होंगे वो कॉल बैक करने वाले। आईएसआर के बाद जो चीजें आने वाली, इंटरप्ट हिट हुआ, वेक्टर टेबल से आईएसआर का एड्रेस एग्जीक्यूट हुआ, करंट सेक्टर सेव हुआ, उसके बाद कॉल बैक चलेगा। ऐसा होता है, या कॉल
यस,
बैक जब होता है। ऐसा ही होता है सर।
या ऐसे ही होगा। आपका जो वेक्टर टेबल के थ्रू, आपको जो वेक्टर टेबल भी नहीं बोल सकते, वो वेक्टर एड्रेस होता है। उस एड्रेस पे आपको आपका वो फंक्शन ना रन रन किया जाता है उस फंक्शन के थ्रू। ठीक है। और उस फंक्शन के अंदर में आपका फिर कॉल बैक फंक्शन होता है, जो आपका दूसरा जो जिस जिस तरह से आप बात कर रहे हो। ठीक है। और फिर आप उस कॉल बैक फंक्शन के अंदर में आपका जो प्रोसेस एग्जीक्यूट करना है, वो प्रोसेस आप आपके उस कॉल बैक फंक्शन के अंदर लिखते हो। ठीक है।
ओके जी।
या मैं को हाल के थ्रू मैंने कभी भी ऐसे कॉल बैक कभी किया नहीं है, कि मैं बेर मेटल वाला बंदा था। एंड आज ट्राई करते हैं किस तरह से कर पाता हूँ कि नहीं। ठीक है। थोड़ा थोड़ा आइडिया है,
ओके।
पहली बार करूँगा आपके साथ में। ओके।
हाँ बिल्कुल। ओके।
ठीक है, अभी सबसे पहले ऊपर जाकर के हम इस बेरिंग वाले बटन को दबाएंगे, तो आपका कोड बिल्डअप हो जाएगा। ठीक है, आपको कोड बनाना है। ठीक है। हम यहाँ पर आ गए, जनरेटिंग कोड। ओके, हमें एक दो चीज़ें और देखनी पड़ेगी, जैसे कि हमारा
हाँ हाँ।
यूआर्ट है। तो यूआर्ट हमारे कौन से पिन पे हो रहे हैं? हम यूआर्ट 1 को यूज़ करने वाले हैं, जो एपीवी 2 का पार्ट है। ठीक है। तो एपीवी 2 में यूआर्ट के पिन हमें कहाँ कहाँ पे मिलते हैं, हमें इसी चार्ट में मिल जाएगी। तो हमें यूआर्ट 1 है, तो एपीवी 2 में मिलता है।
हाँ, अभी जो हम यूज कर रहे हैं उसके अंदर हमारे पास सपोर्टिंग फाइल्स भी तो आ रही होंगी ना, क्रिएट करते हैं तो।
वेल, क्रिएट करते हैं, पर हमने उसका एक्टिवेट नहीं किया, तो हमें सपोर्टिव फाइल्स अभी तक उसने जनरेट नहीं किया है।
नहीं सर, जैसे हम यूआईडी में जाएंगे, हम न्यू टेक्स्ट फाइल्स करेंगे, तो डॉट है, जो डॉट से हम खुद की भी लिख सकते हैं, वो तो प्योर बेयर मेटल हो जाएगा ना। अभी
वो
जो हम।
कंप्लीट वो प्योर बटे बेयर मेटल हो जाएगा, अपन काफी सारे लोगों को प्योर बेयर मेटल समझेगा नहीं ना।
अच्छा अच्छा, ओके
और
ओके।
हमारे पास में उतना टाइम नहीं है लोगों को सिखाने के लिए।
ओके।
उतना बेयर मेटल जाने की भी जरूरत नहीं है ना, क्योंकि मोस्टली ज्यादातर जो इनका बेस लाइन कोड रहता है, वो इनका परफेक्ट रहता है। और हाल लाइब्रेरी जैसे कि 100% आपको फ्लेक्सिबिलिटी नहीं देती, तो इस कंडीशन में हम इसका यूज करते हैं।
ओके।
ठीक है। अब ये देखो, हमारे पास में जो यूआर्ट की जो लाइंस है, वो हमें मिल रहे हैं इन यूआर्ट टीएक्स और आरएक्स मिल रहा है पीए 9 और पीए 10 में, ठीक है। और वो अल्टरनेट फंक्शन है AF7 है। ओके। तो हमारा अल्टरनेट फंक्शन 7 है, मतलब कि हमारा 15 डिवाइडेड बाय 2। देखिए चेक करेंगे, अल्टरनेट फंक्शन 7। ओके। 2 है मम्मी, क्लास में चेक। हाँ हाँ हाँ, हो गया सर। ओके। ठीक है, तो हमें कई सारे नंबर्स याद रखने हैं इस वक्त, क्योंकि हम बेयर मेटल में काम कर रहे हैं, तो हमें काफ़ी सारे चीज़ें मैन्युअली करनी पड़ती है। ठीक है। हमें दो चीज़ें याद रखनी है। सबसे पहले कि हमारा अल्टरनेट फंक्शन कौन सा है, A7। अब देखिए, अल्टरनेट फंक्शन, हर पिन के अल्टरनेट फंक्शंस होते हैं। तो ये हमें सभी मिल रहा है AF7 पे। तो हमें मिल रहा है UART 1 मिल रहा है AF7 पे, RX TX। तो हमारा TX मिल रहा है PA TX। क्या मिल रहा है?
9
या TX 9
PA9
पे मिल रहा है और RX मिल रहा है हमें PA 10 पे, ठीक है। अल्टरनेट फंक्शन 7 है, ठीक है। और ये उसके GPR पिन भी हमें मिल गया है कि कौन से वाले यूज हो रहे हैं करके, ठीक है। तो ये काफी इंपॉर्टेंट इन्फॉर्मेशन थी, इसको हम डायरेक्टली जाके कोड इन कर सकते हैं। तो हम यहाँ पर आ गए, ठीक है। तो हमारा UART और एवरीथिंग ऑलरेडी रेडी है हमारे लिए, जस्ट एक्सपर्ट, ठीक है। हम डायरेक्टली यहाँ पर ही कॉल करेंगे, इस पे बहुत ज़्यादा कॉम्प्लिकेटेड कोड नहीं करने वाले। सबसे पहले हम जब GPIO A का यूज़ करने वाले हैं, तो हम यहाँ पे कैसे टाइप करेंगे, हम लाइक सूडो वेरिएबल काम करने वाले हैं, जैसे अंडरस्कोर हाल और CC अंडरस्कोर GPIO A, ठीक है। क्लॉक इनेबल कर देंगे, हम डायरेक्टली तो तक जा नहीं रहे। उसके बाद में हमारा जो दूसरा कोड इनेबल करना है, क्या करते हैं, पहले काम करते हैं, GPIO को ही इनेबल कर लेते हैं, ओके। अभी मैं एक चीज़ पूछ रहा हूँ, हम यहाँ पे एक्चुअली में सूडो बेयर मेटल प्रोग्रामिंग करने वाले हैं, ओके। क्योंकि मैंने पहले भी आपको बताया है कि पुराने कोर्सेज में कि GPI कैसे करते हैं, हम GPI पे ज़्यादा ध्यान नहीं देंगे, ओके। तो यहाँ पे क्या करना है, GPI, ठीक है, GPIO, फिर हम कौन सी यूज़ करने वाले हैं, 10 और 9, ठीक है। GPIO पिन 9 and GPIO पिन 10, ओके। GPIO 9 और 10 यूज़ करना है। GPIO, उसके बाद में हमें क्या करना है, मोड, जो कि हमारा होगा अल्टरनेट फंक्शन मोड, GPIO मोड, उसके बाद होगा अल्टरनेट फंक्शन पुश पुल मोड होगा, ठीक है। ओपन ट्रेड यूज नहीं करना है, अल्टरनेट फंक्शन यूज करना है। UART GPIO डॉट पुश पुल यूज नहीं करना है, पुश पुल को हम क्या कर देते हैं, पुश पुल को लिख देंगे GPIO नो पुश पुल, ठीक है। GPIO डॉट स्पीड, GPIO इसको हाई स्पीड कर देंगे, ये हाई कर देते हैं, ठीक है। और फिर उसमें UART GPIO डॉट अल्टरनेट, उसमें हमें एक तरीके से है GPIO अल्टरनेट फंक्शन 7 था हमारा, ठीक है। GPIO, ठीक है, अल्टरनेट फंक्शन 0 था, AF 7 था हमारा, AF 7 UART 1 ये दे दिया। तो हम डायरेक्टली उसको एक्टिवेट कर सकते हैं। हमें क्या करना है, हाल GPIO इनिशियलाइज GPIO A, वैसे ये सूडो बेयर मेटल कोड है, ठीक है, मतलब प्रॉपर बेयर मेटल नहीं है। ये इतने फास्ट गिरेगा हमेशा करने के लिए, ठीक है। तो मुझे थोड़ा प्योर बेयर मेटल भी यूज़ कर सकते हैं, क्योंकि हम UART में भी करने वाले हैं, UART कोडिंग में, ठीक है। उस टाइम मैं ऐसे ही कर देता हूँ, ठीक है। तो इस पे हमने हमारे GPIO को एक्टिवेट कर दिया अल्टरनेट फंक्शन 7 पे, ठीक है। अभी हमें क्या करना है, हमें एक्टिवेट करना है UART 1 को, हाल और CC APB2 था हमारा, APB2 नहीं, और फिर ये USART 1 क्लॉक इनेबल, ओके। हमने डायरेक्टली हमारे UART से क्लॉक को इनेबल कर दिया, ठीक है। अब सबसे इम्पोर्टेंट पार्ट हमें इसका एक्टिवेट करना है, वो हमें हमारे स्टेटस रजिस्टर को, और स्टेटस नहीं, हमारे कंट्रोल रजिस्टर को एक्टिवेट करना है। और हमें हमारा ये चेक करना है, क्या कहते हैं, फ्रीक्वेंसीज को चेक करना है। ओके, हम बेयर मेटल के थ्रू करेंगे। कोई हमें बताएगा कि हमारा APB2 का फ्रीक्वेंसी भी क्या है? हम्म,
84 84 84
84 मेगाहर्ट्ज है। ठीक है, हम दो चीजें करने वाले हैं अभी। सबसे पहले तो हम हमारे AI भाई के पास में जाएंगे और पता करेंगे कि हमारा जो बाउट रेट को जो हम सेट करते हैं उसको कैसे करते हैं। ठीक है, BR रजिस्टर में डेटा भरना है, तो हम फिर जाएंगे चेक करेंगे कि भाई हमारा कैसे डेटा इनपुट हो रहा है। तो हमें सबसे पहले कैलकुलेट करना है कि हमें जो फ्रीक्वेंसी चाहिए। अब मुझे कोई बताओ, UART के लिए हम कौन सी फ्रीक्वेंसी यूज करें?
सिस्टम की,
हाँ,
जो जिससे हमारा क्लॉक
9600 RS 11
बस वाली जो
स्ट्रीट।
बस वाली फ्रिक्वेंसी
कितना यूज करना है,
एटी
एक
फोर
जन बताओ।
84
अरे 84 हमारा तो क्लॉक फ्रीक्वेंसी है, हमें UART के लिए कोई एक फ्रीक्वेंसी यूज करनी है हमें।
बस का जो फ्रिक्वेंसी 84 मेगाहर्ट्ज है ना।
अरे यार, मैं UART के लिए पूछ रहा हूँ, UART की क्या बाउट रेट क्या रहना चाहिए?
See, frequency is nothing but baud rate. What is the difference between baud rate and frequency? Both are same, right?
बोथ आर प्रैक्टिकली सेम।
Yeah. See, based upon baud rate, it will based upon distance we have to select baud rate or else what?
Yeah, that's the kind of thing. Yeah, lower baud rate mean higher the distance cover.
Yes, yes.
Yeah, let's just calculate with the frequency here. We can calculate it like 9600. Just take it like 9600 standard frequency. Let me just open the paint here. Where's the paint? Can you tell me what is the name of the paint that drawing stuff? Hello?
पेंट है, पेंट
Yeah, paint.
पेंट
P
PINT
P I N T. Okay. PINT.
PAINT.
Okay. Maybe I lost that paint.
It is
This is the
available.
paint? Yeah, this is the paint. Maybe we had. Okay, we kind of need to download this old school software too, I think.
You can use the draw.io software.
What?
Draw.io. Draw.io.
Draw.io. It is like web-based.
Free. Oh, yes, yes. That's it. You can easily download the pages.
Okay, let's do this. Let's go to the web-based one. Okay. I'm pretty sure my system is running at like full capacity right now. Okay, my laptop
Just
is
close
also
the
completely hot. I do need to take like a one stand for my laptop too. Okay. Draw.io, right?
yes.
What the heck is this? It's like DROW, right?
So, yes, yes, yes. Yes, yes.
Yeah.
I also paste the link in comment section.
There is a .io.com. It is.
Okay, so
Yeah. Learn diagram software. Please ensure JavaScript is enabled. Okay, it does need a JavaScript. Okay. This one is right for. I do need on a whiteboard here. How can I get a whiteboard?
Okay, just a minute.
Okay, screw this. I don't have time. Let's
Mhm.
see. So,
पढ़ने पे भी जोर दे दो, ये नाटकों पे दिया हुआ है। पेपर ही खत्म नहीं हुए।
software install करना चाहिए पहले से. User AI feature. Something also. Okay. While it is downloading, we can go and see the remaining registers we need to like code here. Okay. Let's get to this here. We are actually going to setting this specific register UART BRR pocket register, and also the this control register too. Maybe like this one is like control register. Like this is the status register. Okay, we are going to code the uh, control register 1 only, not the control register 2. Okay. Let's like configure the. Let's just use like the coding which we can do already right now. Like this will be like yes, C1 CR1. Okay, let's just disable the CRT underscore CR1 UE. Okay, disable UART. Then just configure USART1
So
CR.
CR1 is the control register one, na?
Yes, it's control register 1.
Okay.
USART CR1 transmit enable. Okay, and second one will be USART CR1 receive enable. Okay, this putting system figure is like TXCMLB release and it's enable. Okay, all things are enabled. Let's just set the USART 1D or R to what configuration we need. Let me just open the paint. ARMT paint. Okay, let's go to our file here. As we can see, the frequency divided by 16 into baud rate for the QR, whatever the value you want to divide it. Okay, we're going to take the value with this specific formula. Okay, so I have a question to ask you. Okay, let me just gosh, I need to turn off settings and also turn off my WhatsApp. Yeah, probably going to get a lot of memory space with that. This one is off. We like turn off two more things like this, and this one also take a lot of space. This one, let's see how much memory I'm using. Okay, I'm going to like freed up a lot of space from my memory. Okay, I'm pretty sure I won't be able to use my paint here. Okay, I'm like directly going to ask you, just like open up your like mathematics systems and tell me what value we are going to get it for the baud rate of 9600. Okay, and if you have frequency of 84 megahertz, so what will the division value we are going to get? Just use this formula and tell me that what value we are going to get in. I'm using my mobile phone to calculate the values. Okay, 546.
So it's
Huh? 87.
546.875.
Yeah, that's the value I also get. And 8765 multiplied by 16 is, wait a minute, 0.875 multiplied by 16 is 14. It is 14. Okay, so the top 546. Okay, we have to make it like hex here. Hex, sorry, we have to use a calculator. Calculator. Okay, decimal value of 546 is in hex. It is 222.
222.
Yeah, it is the mantissa. It is 222, and for the factor, which is 0.875, 0.875 multiplied by 16 is 14. Okay, it is 14. So for the 14, we are going to hex value of e. Okay, it is factor. It is e. So the value we are going to put into the BRR, it is 222e. So let me go to the system. It is will be 222e 0x222E. Okay, this is the value we are going to put into the BRR register. Then we are going to what we are going to do is USART1 CR1. We will enable USART CR1 UE. Enable. Okay, so let's write a small code to like transmit all the information we want to send to like uh, out of this microcontroller. Okay, so we can like clearly see that what's actually happening. Okay, let me just write a small code here, which are a while loop. We have a status register to check that was the transmitter register is empty or not. Okay, we will wait until you it's not status register. So one is status register. We are going to do it with UART status register TXE transmitter empty. Okay, and we are just going to dump a value into our DR register with a register, and we are going to dump like 0xAA. Okay,
Sir, can you explain this while under the while loop, like while not you are T1, you are one SR, this line?
okay, so you want to know why I actually put a not sign here, right? Let me just make
Yes.
it more simpler for you, so you will like understand why I should give it. Okay, as long, all that means zero. Okay,
Okay, okay.
now you understand it.
Sir, sir, can we also use negation symbol instead of not symbol?
No, we can't. Negation means well, if it's zero, it just make it one.
One. Okay, okay.
Yeah,
Yeah,
just
we are
invert
not
that.
using.
Not
We can make it. We can make it a negation symbol. It may actually going to work, but I've never seen of anyone to do it. Uh, I've never seen anyone do it. Yeah, we can use it, but I never did it and never seen any person do it. Yeah, and probably if you do it, maybe some idiot come around you and say you that you are an idiot. It do going to work, but I never seen anyone do it. You are free to go. You're free to try. Okay, let's just compile all this code and see how many errors I am actually getting here right now. Let's see if I get like a lot of errors today. Probably 100 or 200 errors at the same time.
So if it is making sense, then we can use it. We can try use.
Yeah, we can try it also. Okay, let's see if I'm getting a lot of error today. Okay, let's see how many errors I'm going to get. Okay, how many errors do I have? Okay, it's a lot of error, right? A single digit. Okay, it doesn't matter if you get an error or not. The most important thing that is your software works or not. Okay, the most important part is your system works or not. That's the most important part we need to consider. I really need to like switch like Linux. Windows is like super bloated kind of software and it's just making life bad, bad, bad.
सर ये हम यूआर्ट यूज तो कर रहे हैं कम्युनिकेशन के लिए, बट ये हम कम्युनिकेट कर किससे रहे हैं? एमसीयू टू एमसीयू कम्युनिकेशन?
नहीं, एमसीयू टू टर्मिनल कम्युनिकेट करने वाले हैं।
एमसीयू टू
टर्मिनल।
टर्मिनल? विच टर्मिनल आर यू टॉकिंग सर?
वेल, प्रोटीज में टर्मिनल अवेलेबल आता है जैसे हम लोग कंप्यूटर से करते हैं ना, यूएसबी टू टीटीएल कन्वर्टर, वैसे ही समझ लो।
ओके ओके, ट्रांजिस्टर ट्रांजिस्टर लॉजिक।
हाँ। 401 अब रीसेट को हम पॉजिटिव दे देंगे। तो हम किसी किसी को याद है कि हमारा कौन सा यूआर था, 10 और 9 था, याद है?
यस सर, यूआर्ट 1 का 9 और 10 नंबर की पिन।
9 और 10 नंबर था। तो हम देखते हैं यहाँ पर, तो हमारे पास में वर्चुअल टर्मिनल अवेलेबल है। ठीक है, ये हमारा वर्चुअल टर्मिनल है। तो हम इसकी सेटिंग को भी कर सकते हैं। ये 9300 पर सेट है। तो हमारा 10 नंबर जो है वो RX था, मतलब कि इसका TX रहेगा। 10 नंबर इसका TX रहेगा और हमारा 9 नंबर इसका RX रहेगा। ये सिर्फ नॉर्मल AA भेजने वाला है। ठीक है, हम देखते हैं इसमें क्या डेटा हमें मिलता है। It will be garbage, but it will be something. Project to my student grammatical debug. We only have like L4. I don't want L1. I actually want .hex file. Build apply and close. Custom build. अभी ये जल्दी build हो जाएगा. That's more fast. Let's see if we can do that. We got hex file too. 16 KB. Let's say yes and just run the code. simulation running. Okay, remaining codes are activating. The virtual terminal is showing nothing here. It does sending a lot of commands to the system. Some issues are going on. Okay, yeah, so not able to see. Let's see. Just a bit megahertz. It was like 16 megahertz. Let's see if we're able to get some information. Okay, okay, there is no information. My controller like works. Let me just see if I can send some information. Basically, is not available into this. No. ASCII. Okay, we are still not able to get any information out of like, this database, but we can do one last thing here. Okay, let's recompile it and reconnect to like probe here. Okay, you guys will see an oscilloscope here. Let's just change it position. We may be able to see like the waveforms. Okay. Okay. Here maybe you are now able to see the waveforms, right? It's like high low high low high low, right? Hmm?
Yes, sir.
Yeah. You actually able to see the active type like 0 A, right there. It is like 1 0 1 0 1 0. Okay. 1 0
Okay.
1 0 1 0 1 0. Okay. The same thing you can see here. There will be like a 4 zeros. Sorry, 4 zeros and 4 ones, and one is missing because one is like completely zero. Okay. So that's why one part is like missing. Okay. So the UART like it does communicating, but as you can see, it's like in a super small, super slow speed, and the system and the simulation is like not like super perfect to like capture what's actually happening here right now. Okay, and so the system won't be able to like catch up anything. Okay, but the simulation does work and the communication will do work. Math is correct. The data reception and transmission is not properly showing up in the simulation simply because the simulation is running in a super slow speed. That's why. Okay. Yeah. I actually have to show this one in like real projects. Only then it's actually going to work. Yeah. Let me like do other code here. Okay, any questions? We actually have to make like a receive code also, but it's not like super complicated to understand. But even if you try, you can make that one happen too. Okay, any questions?
Sir, sir, in real projects, where we gonna use this UART, sir?
Practically everywhere, probably in most of your projects.
Sir,
Even GPS models since works based on TX RX communications. So we need